We mentioned that there are two main different types of energy, kinetic energy and potential energy. So let's talk a little bit about the difference between them. So kinetic energy is basically energy of motion. So in other words, if we have energy that's due to motion of some sort, it's probably kinetic energy. So for example, the most common form of kinetic energy is translational energy. So that's kinetic energy is 1/2 mass times velocity squared. Well, but if you think about it for a second, we've already talked a lot about velocity and the fact that velocity is a vector. So what do I mean by velocity squared? Well, this really is saying the kinetic energy is 1/2 mass velocity, the dot product of velocity. So we remember that if we take the dot product of a vector with itself, because that's what we have to do when we're multiplying vectors, then we get a scalar out of it. So we have mass, which is a scalar. We just have a number times a dot product, which is another scalar. So this tells us something important. This tells us that energy is a scalar. So I know a lot of you just breathe, a sigh of relief, knowing that we finally, we're dealing with something other than vectors for now, because scalars are much easier to work with. And so we also notice that because kinetic energy is a function of velocity, that tells us something about the momentum, right? It tells us if we have, a constant velocity, that means we also have, the kinetic energy is also constant. All right, so let's look at the other form, the other main form of energy, which is potential energy. Okay, so potential energy is energy that's due to position. Really, it's energy that's due to the four fundamental forces, but those all, are related to an object's position. So we can think about potential energy as energy that's due to position. Okay, so I think to understand potential energy, it's easiest to just look at some examples. So for example, gravitational potential energy is mass 1, mass 2, times some constant g that we'll discuss later, times the distance between them. You have the potential energy due to a spring, which is 1/2 a spring constant k that we'll talk about later, times its position squared. You have potential energy that's due to gravity near the surface of the Earth, and that's just the mass times the gravitational acceleration at the Earth times the height you're above the Earth, h. We have electrical energy, which is just charge 1 times charge 2 times a constant. This is a different constant k than the spring constant over the distance between them. So again, we look at the potential energy and we see the same thing that we saw with the kinetic energy, which is that all of our terms that have to do with position are all either magnitudes, or in this case a dot product, right? X dot x. So once again, we see that potential energy is also a scalar, because we're saying that energy is a scalar. So we couldn't have one form of energy that's a vector and another form that's a scalar if we're adding them all together. Okay, so that's it for potential and kinetic energy. So now we can start to explore these and start talking about both of these a little more.